Have you ever considered what happened before the Big Bang?
Basically, there are three explanations.
Okay, number one.
Okay, God.
The Bible says that God set the universe into motion.
Number two. that one I understand.
Right. Accident.
Okay,
Right,
that
the
strains
picture being-
credulity just
Right.
by on its
strains
face
credulity.
value.
Right.
So it's an
Right.
accident just that way, and it happens to work out perfectly.
You know, P.W. Bridgman, who was a philosopher of science, defined coincidence as what you have left over when you apply a bad theory.
We physicists say that the universe was created in a Big Bang 13.7 billion years ago. But then the question is, why did it bang? What set off the bang? We don't know. It's a big mystery.
The universe is a put-up job. In other words, this can't be just a happy accident. This is too significant for that. There must be something behind all this.
All we know is that from what may have been nothing, we go to a state of almost infinite density and infinite temperature and infinite violence.
Understanding how nothing turned into something may be the greatest mystery of our universe. But if you understand that, you start to understand the Big Bang, when time and space began, and a great big explosion created everything.
The belief that the universe sprang from nothing in a single moment. Well, if you can make that leap to believe that, it's very hard to see what you couldn't believe. That is almost the limiting case of credulity, I would think, you know? So,
How could something arise from nothing? And what's amazing to me is that the laws of physics allow that to happen. And it means that our whole universe, everything we see, everything that matters to us today, could have arisen out of precisely nothing.
you know, one of the things that's always puzzled me about the Big Bang is it's a singularity. This is the term physicists use for it.
A singularity, where all of the laws of physics as we know them break down, including the notion of time itself.
This means theory cannot predict it, and yet it is necessary to make everything which follows from it happen. So you just say, you know, there's no reason for this, we have no argument for this, but the rest of the theory needs it. So it's a singularity, and the immense improbability which modern science rests on but cares not to discuss is this: the belief that the universe sprang from nothing.
The philosophers in ancient times used to say, how could something arise from nothing? And what's amazing to me is that the laws of physics allow that to happen. And it means that our whole universe, everything we see, everything that matters to us today, could have arisen out of precisely nothing.
It's one of the biggest hurdles to understanding the Big Bang. First, you have to buy into the premise that something was created out of nothing.
The universe, the laws of physics, the fundamental constants of physics are fine-tuned in such a way as to bring us into existence. For example, if the gravitational constant was a little bit different, there would be no stars, there would be no galaxies, the entire universe would just be a uniform splurge of hydrogen, for example.
The very structure of our universe is determined by these numbers. These are the fundamental constants and quantities of the universe. Scientists have come to the shocking realization that each of these numbers has been carefully dialed to an astonishingly precise value, a value that falls within an exceedingly narrow, life-permitting range. If any one of these numbers were altered by even a hair's breadth, no physical, interactive life of any kind could exist anywhere. Wherever physicists look, they see examples of fine-tuning. The remarkable fact is that the values of these numbers seem to have been very finely adjusted to make possible the development of life. If anyone claims not to be surprised by the special features that the universe has, he's hiding his head in the sand.
First, I am by no means convinced that there is a fine-tuning problem, and again, Dr. Craig offered no evidence for it. It is certainly true that if you change the parameters of nature, our local conditions that we observe around us would change by a lot. I grant that quickly. I do not grant that therefore life could not exist. I will start granting that once someone tells me the conditions under which life can exist. What is the definition of life, for example? If it's just information processing, thinking, or something like that, there's a huge panoply of possibilities. They sound very science fiction-y, but then again, you're the one who's changing the parameters of the universe. The results are going to sound like they come from a science fiction novel.
Everything seems to be almost on a knife edge, that if you were to change the rules of physics, the laws of physics, even a little bit, the world as we know it wouldn't exist.
How many of these constants or laws of physics would fit into this category of fine-tuning?
There's debate about just how sharp the knife edge is for, now almost everything, if you changed it very much, the electric charge of the electron, the mass of this or that particle, various constants of nature, how strong gravity is. If you changed it by a few percent, 10%, some of them 20%, some of them 30%, you would really be in trouble. The universe wouldn't look as it does.
Are we dealing with a couple of dozen? Are we dealing?
Yeah, we're dealing with a couple of dozen.
Yeah,
we're dealing
order
with
of
a couple of
magnitude.
dozen, order of magnitude,
Okay.
a couple of dozen constants.
Let's talk about one of them, though, that has some particular strangeness to it, the so-called cosmological constant.
That's right. This constant, whatever made the universe, I hate to say whoever you made the universe. Physicists have a habit of talking in that language, whoever made the universe. They don't really mean it. But whoever made the universe made it with an incredibly small, tiny cosmological constant. It is so small that it is 0.00000. We can sit here for a while.
Yeah.
123 of them.
And then a 1.
And then a 1. I think it's actually a 2. But it is incredibly small, and nobody really knows why. The one thing that we do know is that if it were very much stronger, it would have blasted apart the galaxies. It would have prevented stars from forming. So you have to understand, galaxies and stars and planets formed because gravity pulled them together in the very early universe. This counteracting anti-gravity could have prevented that, could have prevented the formation of stars, planets, and so forth. So if it were just a little bit bigger than this 0.0000000, it would have prevented our existence. Physicists have never understood why it's so small.
Sadly, we just don't know whether life could exist if the conditions of our universe were very different, because we only see the universe that we see.
Basically, there are 3 explanations.
Okay. Number 1.
Okay. God.
Number 2. that one I understand.
Right. Accident.
Okay.
All right,
That
the
strains
picture being-
credulity just
Right.
by on its
Strange
face
credulity.
value.
Right. Well, there's a 4th way.
Oh, 3rd.
I didn't. You want to, let me put the 4th way in before I get to the 3rd.
Yeah.
The 4th way is, who knows? Maybe someday somebody will figure it out.
Oh, sure.
The other way goes as follows. The universe is enormously big. We know that, incidentally. And when I say enormously big, I don't mean like we used to think 10 billion light years. Right. I mean 10 to the 10 to the 10 to the 10th. We have no idea how big it is. Enormously big. We suspect that it is very much bigger than the region we can see. We also have reason to believe that it's diverse, that in different places it has different properties. The picture is that there's some very small fraction of the universe where the conditions just happen to be right for the existence of life. And it's not a surprise, that's where life is. On planets where there can't be water, there can't be life. So it's true, a very small fraction of the planets in the universe are at the right temperature for water to exist. Where do we live? We live in the only place we can live, where water exists. Same kind of picture. Universe very big, very diverse, many different environments, a huge slew of different possibilities. And among these possibilities, in a few small pockets of the universe, conditions are right for life, and that's where life exists. That's the picture. There's mathematics that goes with it. And for those of us who believe in this particular picture of a tremendously diverse, some people call it a multiverse.
You like megaverse?
I like megaverse.
If we are in a multiverse where the different constituents are governed by different physical laws, then we have to introduce a concept called anthropic selection. The idea that we are not in a typical universe, because most of them will be sterile or stillborn, because the laws governing them won't allow complexity to emerge.
The anthropic principle is the idea that our universe is fine-tuned to allow humans to live. A small fiddle with the strength of gravity, for example, and life as we know it would not exist. A coincidence that does not sit easily with scientists. The concept of a multiverse neatly addresses this problem. Within the infinite number of universes that could exist, we are simply living in the one we are able to.
Things are about to get weird, okay?
Things are about to get...
It's called the many worlds theory. There are many, possibly an infinite number of realities that are created and even constantly being created.
In the many worlds theory of the multiverse, every possible outcome would be manifested. So our entire universe and everything within it, including you, would be constantly undergoing multiple fissions into daughter universes, each with its own reality and future. Any given observer, though, would only see one outcome.
Every single thing that could have happened, every single thing that is possible, has happened / is happening somewhere else. So here's an intriguing way to think about that. You got up this morning and you made a series of decisions, and there's just a mind-blowing number of possibilities about what you could have worn for that day, what you could have said to your wife.
There's an infinite amount of universes where you got that dream job, but you also suffer from perpetual panty maggots. An infinite number of solar systems where the sun is called Steve and the earth is called also Steve. Other worlds where salad is delicious.
And
it's a crazy idea.
So everything that could happen has happened in every single combination.
There is a you that got attacked by a cougar this morning, because that could have happened.
There's an infinite number of universes where the only thing different is the placement of a single atom, or the position of a single ginger hair in a takeout cheeseburger. The possibilities of an infinite universe are astounding. They are literally too vast for human minds to comprehend.
Many of you right now, as I say this, you're like, this is obviously not true, and how could you ever prove it? And that's fine if you think that, and I may even think that, but it's not just some weird idea that some science fiction writer came up with.
This is good for the movies.
Right. They've made observations out there that have suggested that this could be a legitimate theory, okay? And it is in dispute. Let's assume just for a second that this is true. This is the way the reality works, right? Okay. It isn't just things that are possible, it's things that can be imagined. That means there's a universe out there, potentially, where Superman is real, where Batman and Bruce Wayne, because it can be imagined, where Hogwarts is a real school and Harry Potter is there right now doing wizardry.
That's where it doesn't make as much sense to me.
It doesn't make any sense. It's not supposed to.
When you can imagine something, that's different than what I do understand. Okay. Like a matrix of scenarios and choices that all are interconnected and lead to
it does
realities.
Make sense, right? And okay, so I'm not here to comment on the validity of the theory. It does seem like a crazy idea, but it's fun and entertaining to think about.
I claim the multiverse is amazingly simple. It is not a theory, it is the prediction of physical theories that are themselves quite elegant, small, and self-contained that create universe after universes.
So you ask what's before the universe, it may be the multiverse. But now,
Now.
Do scientists have evidence that are suggestive of a multiverse?
So we've been driven to it because of theories that actually do describe nature. And so those same theories can be tested. And so, in fact, just like we knew atoms existed before we could see them, okay, it is true that if there are many universes, we're subject, and in my own field, I'm constantly reminded that we're limited, that we live in one universe. And therefore, there are some questions we can't empirically test directly.
That doesn't mean some people don't have some creative ideas, but the only real answer is we don't know. And we have top people working on it.
The other huge difference is, however, that if there was any evidence against it, we'd throw it out like yesterday's newspaper. That's not the faith of religion. It's the fact that we make a theory, we test it, and we throw it out with impunity if it's wrong.
It may be impossible to ever directly observe the multiverse, but some scientists hope to eventually gather enough data supporting the theories that predict it to one day confirm its existence.
But the only real answer is we don't know. You ask what's before the universe, it may be the multiverse. But now.
When you point that finger, I get nervous.
So there's also good philosophical reason to think that there's a multiverse, because in our experience discovering the cosmos, the universe never makes anything in ones. When we thought Earth is it, no, Earth is just one of many other planets. Well, the sun is, but no, the sun is one of 100 billion stars in the galaxy. Well, the Milky Way, no, there's 100 billion other galaxies in the universe. If this entity never makes anything in ones, then why would it only make one multiverse?
Jesus Christ!
So then,
broke my brain again. Damn it.
So maybe there are multiple multiverses.
And then you have two different models, theism and naturalism, and you want to compare which model is the best fit for the data. I applaud that general approach.
Some people think God is important to science. It isn't. The point is that, again, as Steve Weinberg said, most scientists don't think enough about God to even know if they're atheists. It never comes up.
Who knows? Maybe someday somebody will figure it out.
We need to understand what's the origin of time and space. What was the universe actually like? I think these are the big questions.
14 billion years ago, there was nothing. No stars, no galaxies, no planets or people. Then suddenly, without warning, everything exploded into existence.
The idea that there was nothing before the Big Bang defies the most primitive of all logics. Physicists, cosmologists, mathematicians, and philosophers have all put forward theories as to what the ultimate cause was, some with more credibility than others.
So here's a mind bender. What came before the Big Bang?
Well, the answer is a Higgs-like boson set off the Big Bang. It put the bang in the Big Bang. See, the purpose of Higgs bosons, and there's more than one, the purpose of the Higgs boson is to break a symmetry. And when you break symmetries like the symmetry of the universe, then you get Big Bangs. So what is the Higgs boson? The Higgs boson is a fuse. It's a match. It's the spark that set off the Big Bang.
What came before the Big Bang?
The singularity that arises for no reason in absolutely empty space instantly is the least likely of all singularities. Doesn't it seem more likely, if we have to have a singularity, that it occurs in a domain with a rich history, with many causal streams feeding into the situation that nurtures the complexity? In other words, to put it simply, if you have to have a singularity, doesn't it make more sense to put it at the end of a cosmogonic process than at the beginning?
You ask what's before the universe, it may be the multiverse.
The
Big Bang is not the beginning, that there's something that comes before, and that we can actually trace things back. Well, one of the ideas that some of us have been thinking about is that, in fact, there was a universe evolving before the Bang, a universe that went through the same sort of history as we've observed since the Bang, and that the evolution of the universe is cyclical.
So it goes over and over and over again.
That's right.
So of course, people are going to say what happened before that.
That's right.
Before the cycling began.
Well,
you can't get away with that answer. We're too long with this crowd. I can see that.
That's right. Well, I mean, there's two logical possibilities. There was some beginning, but it wasn't the Big Bang. It was some event that occurred many cycles ago. Or one of the interesting ideas is that it could have been cycles forever. Like,
our concept is time is wrong.
That's right.
We know the laws of physics as we now understand them break down, and it could be that time itself wasn't a relevant quantity at the beginning, so the answer to what happened before the Big Bang is it's not a good question.
Not for you, but...
Around the world, are people as disturbed at the need to have a first cause? Because that's what's driving all this. It's like, well, how did it get here? I have to know. It is a problem to be solved.
Let me, look, we don't need the point is science doesn't worry about a first cause. I mean, you're pretending it does, but it doesn't. Religion does. First of all, there are lots of good physical definitions of nothing, and I still think the best physical definition of nothing is the absence of something. So to understand nothing, you have to understand.
We're done.
You have to understand what something is. That's why it's a physical question and not a philosophical one. First, you have to understand what something is, and you have to understand what the absence of that is. All those are physical questions, and physicists try to answer them. Now, there are a number of different answers which we can get to, and Rich has talked about some of them. There's still the simplest thing is not to take it to zero radius, which is, as Eva pointed out, is not physical. At least most of us think it's not physical. When you apply quantum mechanics to gravity, and we don't have a quantum gravity theory yet. Some people think we might be getting close, but we don't know if it is. But one of the things is quantum mechanics says things fluctuate, and if gravity is a theory of space and time, if you make space and time quantum mechanical variables, then it is perfectly possible for universes to pop into existence. Space and time to pop into existence where there was no space and time before.
Hold on.
Now,
hold on.
I haven't had a chance to talk yet.
Hold on. I must ask a question here.
What?
Space and time pop into existence. You make that sound like a temporal process, a process in time.
Well, because I said so you can understand it.
Huh?
No, I mean, I used words, and the problem with words are, as T.S. Eliot says, they're sort of slippery.
How about this? But becoming implies time. You can't have time coming into existence as itself a temporal process. That makes no sense. That's why it's good to have philosophers around, which I'm not one to help you use language precisely.
And so let me just pretend let me just say that there's a global time, and at some time a space pops into existence. Okay, will that make you happier? Okay.
Why don't you like his nothing? That sounded like a good
Well, first
nothing.
of all, as he himself admits, his nothing is a something. And
Well,
when you start with a
what is
contradiction,
the
you can
something?
derive anything.
Let me get to the point. The key point is this question. First of all,
It's
the
a
question
physical
why is there
object.
something.
It has structure. It obeys laws, complex laws. There's a lot of stuff going on. I mean, my bank account, where there's no money in it, is still something. And, and the vacuum is a hell of a lot more of something than my bank account.
Okay. Well, no. The point is that the key question is really the why question is stupid.
So why is it there instead of not there?
Or instead of something else.
Really, the why question is stupid. Okay, everyone who has kids knows that.
Wait, which why question are you talking about?
Eventually you keep saying, why, and the only answer is go to bed. The question that really matters, and it may not be the question that matters to some classical philosophers, but it's the question that really matters is, how did a universe of 400 billion galaxies containing 100 billion stars, how did that come into existence if there weren't galaxies, if there weren't stars, if there wasn't energy? And that is the question that physics is coming close to answering. And that may not be the ultimate question of whether there was nothing before that, but there was nothing, our universe didn't exist. And our universe coming into existence when it wasn't there in the beginning with zero energy, but still enough gravity to create everything we see is the amazing, remarkable miracle that science creates. And that's the important question.
Yeah, it's a great story. There's lots of empirical evidence for it. You've told a miraculous story about how
a universe like ours was spawned by a piece of rubber. But where did the piece of rubber come from?
No, and the point is that even the laws don't have to exist. There could be in the
Wait.
multiverse.
You said a quantum fluctuation brings the universe into
That's
existence.
because I can talk in our universe about quantum mechanics, but it could be, although this is wild.
Nothing else we've been talking about until now is wild. But this is wild. Okay, go.
This is even wilder. Okay, so it's quite plausible. In fact, if there are many universes, as current theory suggests, that in each of them, the laws of physics essentially come into existence when the universe comes into existence. There are different laws of physics in each universe.
Then you can't invoke a quantum fluctuation to give you the universe that has quantum fluctuation.
But what is interesting to me, and I have no mathematical underlying theory of this, but it's perfectly possible, it seems to me, that some of those universes don't even have quantum mechanics. I will accede that the philosophers and theologians are, know much more because they are experts at nothing.
Not even universe.
Wait. So just Lawrence, just to close this out. So your universe that's created out of nothing, where there are no laws, no space, no time, no anything. That nothing had to know to create the universe.
Well, there may have been something else there, but our universe was
now
there.
you confess. I'm just trying to understand, because if there's no laws, then there's nothing to know to create a universe.
What if there's every law? Is that the same as no laws? That's the point.
I bet.
Well, I think Jim was sort of saying.
I wasn't
Jim
listening.
was alluding that to every possible law, every possible universe. There may be universes with no laws. There may be universes with laws. That's certainly a possibility.
All I'm saying is, if you have a place, whatever that is,
there was no place.
If you have a no place with no laws, and then you birth a universe, something in that place had to know to birth that universe.
Why?
Really, the why question is stupid. The only answer is go to bed.
Okay.
Why, if it's possible, why do you have to? You're assuming intentionality. You're making this.
You're purporting to offer us an
theology.
explanation, and you're offering us no explanation. All you're saying, it just is.
Yeah.
The creation myth is always about how the world we live in came into existence. It may have evolved from an earlier chaotic state, or it may have been created out of nothingness by a god or something like that.
As unusual it is to imagine a universe beginning from nothing, in fact, it's not so crazy, because one of the reasons a flat universe is so pretty for theorists is if you add up the total energy of a flat universe, it adds up to zero.
It's the biggest mystery in science to try and understand where the energy we see in the universe comes from.
And that's one of the many reasons why all of us, Paul even a decade ago probably, would have argued that the universe was flat, because if you're going to imagine a universe that began with nothing, a good value for the total energy is zero.
It might be hard to make a universe out of nothing, particularly relying on something that by definition didn't exist. So we thought, well, maybe the universe isn't made out of nothing. It's made out of something, and that something could be itself.
Well, I think you have to be a little careful. And Rich is right. The first definition of nothing, which I think is the biblical definition, is an infinite, dark, empty void. That empty void has energy, but it's still empty. There's no particles. You try and look in a region of space, take away all the particles, all the radiation. There's no stuff there, and that's nothing weighs something.
Larry, what about fields? Physical laws? What about mathematical entities? What about, consciousness, value, all the things that are possibly non-spatial, non-temporal? Those aren't ruled out, so it seems to me that the notion of nothingness is a very parochial
We'll get back. You raised a really important point that I want to get back to. What you're saying is you could have a universe that's got nothing in it, but if laws of physics still apply in that universe, the laws of physics are not nothing.
Okay, it's a physical object. Empty space is a physical object. It's not.
Wait, I want to get back to that. Wait. Rich, you said that you take everything out of space, yet Einstein said there is still the geometry of the fabric of space-time.
Yeah.
Do we have the right to say, because there is the fabric of space-time, even though it's not curved, it's just not bent by any actual matter, does that prevent us now from calling that nothing? Because we have a description for what it is as fabric of space-time.
Well, Einstein.
That's kind of what Jim's getting at, right, Jim?
Yeah.
Yeah, but that's the first kind of nothing. And then point is that's for a lot of people before physicists started talking about that kind of nothing having energy, they would have said that's a good enough definition of nothing for them, empty space. Now we know empty space is more complicated. So you might say that's not nothing, but then there's a next kind of nothing, which is no space at all. No space, no time.
I would say philosophers have talked a great deal of nonsense about nothing.
So Jim, when did philosophers start weighing in on this?
Really with Leibniz in the 17th century. He was the first thinker to pose the question, why is there something rather than nothing? And by nothing, he meant a state in which there are no existence at all. There are no entities, there's no chaos, there's no space, no time, absolute nothingness. It's very difficult to grasp in the imagination. Even when you try to reach nothingness in your imagination, there's still, the little light of your consciousness, creeping under the door. The only times I've succeeded in imagining absolute nothingness is two times. Once
but
during,
you've succeeded.
Yes, once during
under what influence?
Actually, every night during dreamless sleep, and once while I was watching professional bowling on television.
Okay.
Okay, so what does really nothing look like? Well, what does it look like back here? Is there a big black thing back here? A big black cape over here on here? No. not me, though.
Okay, I'll stand over here. Now repeat that. Go. Okay. Go.
It's not black back there. You don't have any retinal cells, looking in that direction. So that's really nothing. It's not anything. It's not there.
So Jim, your best nothing is what?
Not anything. That's the theory of nothingness. I'm sorry, it's no more interesting than that. And that's why, by the way, philosophers spend very little time vexing over the concept of nothingness. It's not that complicated.
So is this just the same argument moving forward?
I think in terms of, there's an aesthetic underlying fight here.
Because Lawrence loves his zero, his universe from nothing. He's aesthetically turned on by that. I can feel it when I walk near him. Okay?
That's just personal attraction.
Rich, you seem to be pretty cool with nothing.
Well, I'd say not there. It's just not there.
So, Rich, is it fair for me, I don't want to stretch your analogy here, because that was a good one. So, people ask, what happens to you when you die? You go to heaven or hell or wherever. And for me, the simplest explanation is your awareness is such as what you knew of the world before you were born.
Exactly.
Right? And so that's as nothing as you can possibly come up, other than Shirley MacLaine, who's been reborn many times. For the rest of us, that's like what's behind your head, right? Because you don't even see it. You don't even know to think it's there. So your consciousness before you were born, that's a pretty good nothing, isn't it? So Lawrence, what is your best nothing?
Well,
is it the whole universe itself? Because I wore a vest for you tonight.
Yeah.
Okay.
Yeah.
I just want to say, I've got the entire universe on my vest, and
I knew it would come out sometime. I knew it.
You tell me all these stars, moons, planets, came from nothing.
Yep. Look, there are a variety of forms of nothing, and different one, and they all have physical definitions, and you might not like any of them, but one is empty space, the other's no space, and the other's no space, no time, no particles, no laws, and that to me is as close to nothing as you can get. And in fact, as I see, I don't see why people have any problems with it. Each of these lights in this room emits a photon. The photon wasn't there before it was emitted. It wasn't in the electron. It wasn't in the atom. It was created from nothing. And some people don't have a problem with that.
No, it was created from energy. Created from energy. Lawrence, it was created from energy. And energy is not nothing.
5, 4, 3, 2, 1.
we look back into our recent past, we discover tremendous epistemic naivete. That means people didn't know what was going on. They weren't even close. And yet we are asked to believe that somewhere after Darwin and before now, it was all figured out. And now we view the universe from a lofty pinnacle of integrated understanding. Now the physics explains biology, biology explains culture, culture explains sociology, so forth and so on. Well, this is really whistling past the graveyard, because meanwhile the visible consequences of this understanding are spreading chaos, a dissolution of values, an inability to control technology, an inability to set reasonable political goals such as moderation of population growth and carry them out. Instead, somehow this deep insight into how everything works has left everything a mess. And what does that mean about us? Why is that, and what can be done about it? And we have, I think because of unique characteristics of the male ego, chosen to operate with the assumption that we can understand, that the human mind can in fact grok larger and larger levels of embeddedness and make sense of them.
Traditionally, we use physics to start with the present and predict the future. You can also do it backwards and start with what we see around us in the present day and calculate what the universe must have been like in the past in order to end up like this.
When the universe was born in the dubious and controversial circumstance called the Big Bang, it was at first simply a pure plasma of electrons. It was the simplest that it could possibly be. There were no atoms, there were no molecules, there were no highly organized systems of any kind. There was simply a pure plasma of expanding energy. And as the universe cooled, simply cooled, new kinds of phenomena emerged out of the situation. As the universe cooled, atomic nuclei could form, and electrons could settle into stable orbits. As the universe further cooled, the chemical bond became a possibility. Out of chemical systems comes the covalent hydrogen bond, the carbon bond, complex chemistry that is prebiotic or organic. Out of that chemistry come the macrophysical systems that we call membranes, gels, charge transfer complexes, this sort of thing. These systems are the chemical preconditions for life, simple life, the life of the prokaryotes, the life of naked, unnucleated DNA that characterized primitive life on the planet. Out of that life come eukaryotes, nucleated cells, and then complex colonies of cells, and then cell specialization, leading to higher animals, leading to social animals, leading to complex social systems, leading to technologies, leading to globe-girdling, electronically based, information transfer-oriented cultures like ourselves. So as the universe aged, it complexified. This is so obvious that it's never really been challenged. But on the other hand, it's never been embraced as a general and dependable principle.
Why doesn't science take that on board as a major problem in the description of nature, the emergence of complexity? Well, you ask a scientist, they say, well, you see, these are separate domains of nature. How atoms become molecules has nothing to do with how animals become human beings. This is bullshit. This is just some kind of compartmentalized thinking where you don't want to come to grips with the overarching metaphors that are working on various levels. The advent of the understanding of the fractal ordering of nature now makes it clear that voting patterns in Orange County, distribution of anemones on the Great Barrier Reef, and the cratering of Europa all follow the same power laws. So that's the first thing which science has staring in the face and has never taken on board. Now, I said there were two things. The second thing is related to the first. A double shot of espresso, you're really getting your money's worth here. The second thing which science has taken on board, has refused to take on board, is that this process of complexification that I just described to you, as you approach the place in time called the present, happens faster and faster. That was not necessarily implied by the first observation. The first observation was simply that there was a process which was moving from simple to complex. Now we add the concept of a process which is ever accelerating as it moves from the simple to the complex. So more and more happens as you approach the present. And since these processes have been running since the Big Bang, there is no argument to be entertained that they will reverse themselves suddenly. No, they're not going to reverse themselves after 13 billion years. Duh. So then, but the implication of that, carried to its ultimate extreme, leads to a conclusion most people find too wild to entertain. If the universe is evolving deeper and deeper into complexity, faster and faster, and if now in a human lifetime we can see a small portion of this curve, it no longer appears flat to us because of our nearness in relation, you understand what I'm saying? We can actually discern the curve. And so that means, I believe, that by extrapolating this process, we should then logically conclude that we are very near, relative to the life of the universe, we are very near to the place where this ramping up of complexity will become so excruciatingly rapid that more change will happen in a single week than happened in the previous 13 billion years, and that then there will come a moment where more will happen in a single minute than happened in the previous 13 billion, and then a moment will come when more will happen in 6.55 times 10 to the 23rd erg seconds. More will happen than has happened. And people say, well, but that's crazy. I mean, what kind of universe is that? Well, wait a minute. What's so crazy about this? Let's look at what the competition is peddling. What the competition would have you believe is that the universe sprang from nothing in a single moment for no reason. Here's what's so great about all this. If you will join me in this belief that the universe works as I have described, it's an engine for the generation of complexity. and it preserves complexity and it builds on complexity to ever higher levels. If you entertain this, guess what happens? It's like a light comes on the human condition. Who are we in my story? Well, first let me tell you, who are we in science's story? We are nobody. We are lucky to be here. We are a cosmic accident. We exist on an ordinary star at the edge of a typical galaxy in an ordinary part of space and time. But if I'm right, that the universe has an appetite for novelty, then we are the apple of its eye. Suddenly, cosmic purpose is restored to us. We left the center of the cosmic stage in the 13th century and haven't been back since. But this idea says, no, people matter. You are the cutting edge of a 13 billion year old process of defining novelty. Your acts matter. Your thoughts matter. Your purpose, to add to the complexity. Your enemy, disorder, entropy, stupidity, and tastelessness. And so suddenly then, you know, you have a morality, you have an ethical arrow, you have contextualization in the processes of nature, you have meaning, you have authenticity, you have hope. You have the cancellation of existentialism and positivism and all that late 20th century crapola that people used to entertain back in the old days. So that's why I am so keen for the idea of novelty, because it seems self-evident.
It's interesting, isn't it? Let me tell you a little story. So this night, I was sitting beside a biochemist. Now, this is one of the world's top biochemists. I said, you're a reductionist. Everything in terms of physics and chemistry. You believe everything can be reduced to physics and chemistry. He said, that's right. That's my basic principle. So I said, let's have an experiment then. So I picked up the menu. And he looked at it, and it wasn't very interesting. It said roast chicken. I said, now look at this thing here, R, O. I said, those are marks, aren't they? But they're semiotic, Greek semeion, a sign. They're marks that carry meaning. He said, that's right. Okay, I said, explain to me the semiotics of those marks in terms of the physics and chemistry of the paper and ink. And there was a silence. And then his wife said a bit loudly, get out of that if you can. He said, John, for 40 years I've gone into my laboratory thinking that that could be done. But it can't. I was so amazed I backtracked. I said, oh, but science has only been going 500 years or so. He said, doesn't matter. You cannot explain the semiotics bottom up. You have to introduce an intelligence. Just a few marks, and you instantly argue upwards and postulate mind. And we sit and look at the human genome. 3.7, is it, billion letters in exactly the right order in a 4-letter chemical alphabet. Sophisticated because the levels of information are contained not only in the linear sequencing but in the folding and in its relationship to the cell and all kinds of things. And we ask about its ultimate origin, chance and necessity. What? Chance and the laws of nature. Seems to me something very interesting is going on. And that semeion, the evidence of meaning, our capacity. Because you see, ladies and gentlemen, we are not only containers of text, we are producers of text. And that, to my mind, is great evidence that there is a transcendence beyond nature. The beginnings of supernature are already to be seen within you.
Mathematics has been appropriated by science because mathematics has an uncanny ability to describe nature. Completely uncanny. Now, you may have never asked yourself, why is mathematics such a powerful tool for the description of nature? Maybe you thought that somebody else can answer this and that it's not a problem. Well, I've got news for you. It is a problem. Nobody has any good ideas about why mathematics describes nature, but notice that mathematics is an intuitional activity. Now, half of mathematics would rise with a screech of horror at this statement, but the other half of mathematics calls itself intuitional mathematics. Okay, well now what's going on here? Probably if you are not a professional philosopher of science, you are accustomed to associating mathematics with science rather closely. This is because science, in order to give itself legitimacy, has very slyly appropriated mathematics, especially in the 20th century, to its purposes. But if we talk about what is called pure mathematics, which is the great love of mathematicians, the other kind of mathematics is applied mathematics, and that's for engineers and technologists and is not, what moves them to the edge of their chair. But if we think about pure mathematics, it is an activity carried on in the mind based on deductive truth. Deductive, not inductive. In other words, a statement is made. It can be anything. All grays are non-X. This is just a statement. We don't yet know what this is going to be about. All grays are non-X. All greens are F sub 1. What we're putting in place are a set of statements that appear nonsensical. But what we will assert is that we should seek a relationship between them and that will then show us something. And this is how mathematics really works. It has very little to do with number. It has to do with the conceptualizing of relationships, conceptualizing them, and then exploring your intuition about these conceptions. And then the third and very late stage is you write a formal statement of your cognitive activity around these assumptions. So you see, mathematics is entirely intuitional. It leaves no track. It is drawn from this other domain. An intuitional activity describes nature without the intercession of inductive science. Inductive science is a kind of naive holdover from Greek Democritean theories, where everything is conceived of as clearly conceivable and operating according to known laws. But in fact, the deeper structure of nature is not modeled out of an examination of data obtained by measurement. That isn't how it works these days. The deeper description of nature is achieved by taking weird objects from the frontiers of mathematics, these things dreamed up in the confines and depths of the human mind and inside computers, and then laying them over nature and seeing, my gosh, there's a one-to-one correspondence between, let us say, the multidimensional catastrophes described by René Thom and the dripping of a faucet, the turbulence in a brook, the voting patterns in a ghetto. All of these things are seen to be easily modeled by extremely exotic mathematical objects discovered through intuition within the mind. must be that the unaided human mind is more capable of correctly modeling nature than the human mind that works through the methodological inductive approach called science. And in fact, this is clearly true, because the world described by science, a scientific description of this room, would say very little about all the important things going on in it. A scientific description of this room would leave out personality, would leave out linguistic intent, would leave out the uniqueness of each of us. For science, we are merely members of the human species. Again, this flattening, this reductionism, this betrayal of the quintessence of the phenomenon in a desperate effort to achieve closure in the modeling process. And so then you do achieve closure, but the model is always inadequate. It's always inadequate. So then there's this sense of frustration. We can't get closure with the model unless we deny the complexity, the interrelatedness, the soulness, the spiritness, the mindfulness. All of these things are, for science, what are called secondary properties. They are epiphenomenal. They are only an aspect of your point of view.
You have to introduce an intelligence.
According to the Big Bang Theory, it all started with a little tiny dot and exploded.
The universe didn't begin in a singularity. Who knows how the universe began, or would even presume to judge? But the universe ends in a singularity. It has been growing more singular, more complex, more unique, more novel every passing moment since it burst into existence. And if that's true, then we represent a kind of concrescence of universal intent. We're not mere spectators, or a cosmic accident, or some sideshow, or the Greek chorus to the main event. The human experience is the main event. The coordination of perception, of hope, of dream, of vision that occurs inside the human heart-mind-body interface is the most complex phenomenon in the universe. And you don't have to be a rocket scientist to see that human society, human history, human art, human literature represent things for which there is no analog. In our species, complexity has turned inward upon itself, and in our species, time has accelerated. Time has left the gentle ebb and flow of gene transfer and adaptation that characterizes biological evolution, and instead, historical time is generated. And so I believe that science and its reluctance to deal with the psychedelic experience and the way in which science has used then law to suppress its rival, in this case, arises out of a profound discomfort on the part of science about this future state of complexification that is clearly the grail, the dwell point, the end point of the human historical process.
Well, the Big Bang Theory, as we'll see in a minute, is stupid.
It's the biggest mystery in science to try and understand where the energy we see in the universe comes from.
The Big Bang idea started with a Belgian astronomer named George something, can't pronounce his last name. George said that this original matter was no more than a few light years in diameter. At the very least, that would be 2, or about 12 trillion miles. So they started off teaching a spot 12 trillion miles across was what exploded. Well, they revised that down. In 1965, they said, no, it was only 275 million miles across. Well, that's way down from 12 trillion. 1972, they said, no, it's only 71 million miles across. I don't know how they know this stuff, but this is what they taught, okay? 1974, they said it was only 54,000 miles across. 1983, they said it was the trillionth the diameter of a proton. Now they're saying it's nothing at all. Nothing exploded. And here we are. This is what the textbooks teach. 18 to 20 billion years ago, all the matter in the universe was concentrated into one very dense, very hot region that may have been much smaller than a period on this page. That's stupid. This one says, all of the matter and energy someday will once again be packed into a small area, no bigger than the period at the end of this sentence. Then another Big Bang will occur. It happens every 80 to 100 billion years. So you can forget about global warming. We're going to get squished. Now this textbook author was brilliant. I could not believe how smart this guy was. He said, boys and girls, nothing really means nothing. You have to be at least that smart to write a book. He said not only matter and energy would disappear, but also space and time. However, physicists theorize that from this state of nothingness, the universe began in a gigantic explosion. What? Yes, boys and girls, you see, nothing exploded, and here we are. Now, who can argue with logic like that? Man, they even put this in major science journals like Scientific American. This fellow said, the observable universe, that would be us, could have evolved, there's that word again, you got to watch that one, okay, 6 meanings, from an infinitesimal region. In the Greek, that means a dot. It's then tempting to go one step further and speculate that the entire universe evolved from literally nothing. They call that science and put it in a science book. I would call that stupid and put it in the garbage. This is what the books teach. I collect them. I've got hundreds and hundreds of these books from countries all over the world, clear back from 1890s up until the 2001 textbooks. They're teaching this kind of stuff, folks. This one says, all the matter in the universe was drawn into this little tiny dot, and it spun faster and faster. This is what they teach the kids. Some kids doing this for homework tonight, right? It spun faster and faster. One day, it exploded. Big Bang. I was talking to a professor from Berkeley one time. I was sitting on the airplane next to a professor from Berkeley University. I don't know if you folks here in Idaho ever heard of Berkeley or not. But Berkeley is not a Bible college. So we got talking about the Big Bang, and he said he believed in the Big Bang theory. I said, yes, sir, I figured that. You have to teach it at Berkeley. I said, tell me, sir, how did the universe get here? He said, well, 20 billion years ago, all the matter was squished in this little tiny dot, and it was spinning real fast, and it exploded. Big Bang. And pieces flew off and became the galaxies and the sun, the moon, the stars, and finally, you know, people. Here we are. I said, sir, could I ask you a couple questions, please? You know, one of my favorite things to do in life is asking questions to people who believe in evolution. I absolutely have a wonderful... That's how this whole ministry started. 12 years ago, I moved to Pensacola, Florida. Some article came out in the newspaper that said, dinosaur bones found in Montana from 80 million years ago. I wrote my first letter to the editor in my life, about 12 years ago. I wrote a letter to the editor. I said, yes, they found dinosaur bones, and yes, it was 40 feet long, and yes, it was found in Montana, but it was not from 80 million years ago. This one probably drowned in the flood in the days of Noah, 4,400 years ago. And you would have thought I shot the sacred cow. Actually, I did. Boy, there began to be quite a battle in the newspaper, letters to the editor flying back and forth, and finally a university called me and asked me to do a debate with one of their professors. Well, I'd never had a debate in my life except with my wife, and I lost those every time. So I was not excited about debating, but I said, well, how do you do it? What do you want? And the guy said, well, you send us 30 questions, and the other guy will send in 30 questions, and we'll discuss those questions for the debate. I said, okay. So I sent him 30 questions. I thought they were perfectly legitimate, fair questions. I said, a woodpecker's tongue goes all the way around the back of his head and comes on top of his left eyebrow, left nostril here. Would you please show me any fossils that have been found, intermediate species between a normal bird and a woodpecker, you know, with his tongue going all the way around his head? What evidence do you have of how this evolved? That question never came up. I don't know what happened to it. But I said, termites chew on wood and they swallow it, but termites can't digest it. It goes into their stomach, and there's little tiny critters in their intestines that actually digest the cellulose. Now, those little critters can't live without the termite, and those termites can't live without those critters. Which one evolved first? I thought it was a fair question, but it never came up. I don't know what happened. I think they lost my list. But anyway, one of my favorite things to do is asking questions to people who believe in evolution. So I asked this professor if I could ask him some questions about the Big Bang. He said, sure, what would you like to know? I said, well, sir, you told me 20 billion years ago all the matter in the universe was squished in this little tiny dot. And it was spinning faster and faster and exploded. I said, where did all this matter come from? He said, well, we don't know that for sure. I said, okay, now, sir, hold it. If I told you that I believe about 6,000 years ago God created the heaven and the earth like the Bible teaches, you're going to say, and where did God come from? And I don't know. But you said 20 billion years ago there was a Big Bang, and you don't know where the dirt came from. So basically, I believe in the beginning God, and you believe in the beginning dirt. Don't tell me my theory is religious and yours is science. Oh, no, sir, they're both religious. The news media tries to make it look like it is religion versus science. I did a debate in El Paso, Texas here recently, and the news media wrote an article. They said, religious and scientific leaders debate evolution. What is the unspoken message in that title? What are they trying to imply? Can you catch that? They're trying to imply that evolution is part of science, aren't they? No, evolution is a religion. Actually, both creation and evolution are inherently religious. These two timelines is the same information right here. I'll be referring to that throughout the seminar here. I cover this thing all the time. The Bible teaches about 6,000 years ago God made everything. 4,400 years ago there was a big flood that destroyed everything. 2,000 years ago Jesus came. Here we are today waiting for the Lord to come back in about 5 minutes. This is the Bible view of history. On this chart, 1 inch is 150 years. That's a long time. The 20 billion year chart on the bottom is a very different scale. But see, both views, creation and evolution, are inherently religious. You have to believe in creation or believe in evolution. The difference between the two, though, is very simple. The evolution religion is tax supported. That's the difference. By the way, if I was to make that bottom chart the same scale as the top chart, the bottom chart actually needs to be 2,100 miles long. That's from Pensacola to Portland, Oregon. I don't want to carry a chart that big, so I made a new scale for the other one, okay? If they want to believe it happened long ago and far away, they're welcome to believe that, but that's not science. Evolution is a religious worldview, and I think it is stupid. So I asked the professor, where did the matter come from? He said, I don't know. I said, well, sir, would you please tell me where the laws came from? The universe is run by laws, gravity, centrifugal force, inertia. Who gave the laws? He said, we don't know that either. I said, sir, could you tell me where the energy came from? You know, it takes energy to make a big bang. Who bought the gas to run this machine anyway? He said, we don't know that either. I said, sir, could I ask you another question? He said, sure. What else would you like to know? Else? What do you mean else? You haven't told me nothing yet. I said, does Berkeley have a merry-go-round? How many of you know what a merry-go-round is? You go round, round, round till you puke, okay? He said, no, we don't have a merry-go-round at Berkeley. I said, you ought to get one. You could learn some good science on a merry-go-round. If you put some fourth graders on a merry-go-round, are there any fourth graders in here tonight? Who's in fourth grade? All right, I like fourth graders. I spent the best 5 years of my life in the fourth grade. That's before they diagnosed ADD. Put some fourth graders on the merry-go-round. I like using fourth graders because they're tough and they're expendable. And we're going to get the high school football team out there to get that thing spinning clockwise as fast as it will possibly go. Now, if you have a digital watch, you may not know what clockwise means. I'll explain it later. We're going to spin the merry-go-round clockwise. The kids are going to go through 4 phases. They start off in phase 1. They're screaming at the football players. Come on, let's go. Faster, faster. Can't you go any faster? You get up around 30 miles an hour. The kids enter phase 2, where they stop screaming. They just quietly concentrate on trying to hang on for dear life. You get up around 60 miles an hour. The kids enter phase 3, where they start screaming again. But now they're screaming, stop, stop, please, slow down. Don't stop, though. Keep going faster and faster. When you get to about 100 miles an hour, you should enter phase 4. That's where the kids begin to fly off the merry-go-round. Now, when this happens, you will notice a very interesting phenomena of physics. If the merry-go-round is going clockwise, when the kid flies off, the kid will be spinning clockwise until he encounters resistance, like a tree or telephone pole. That's because of a law in physics known as the conservation of angular momentum. You see, if a spinning object breaks apart in a frictionless environment, the fragments will all spin the same direction. It's very simple. It's because the outside is moving faster than the inside. And so it keeps the same direction of spin. The professor said, yes, I understand about the conservation of angular momentum. I said, well, good. I'd like to ask you a question then, sir. If the whole universe began as a swirling dot, like you said, Why do 2 planets spin backwards? He said, that's interesting. I said, no, that's more than interesting. It's kind of hard on your Big Bang Theory. Not only that, 6 of the moons are spinning backwards. Why? He said, I don't know. Why do you think they're going backwards? I was hoping he was going to ask that. I said, well, sir, I believe it's very simple. You see, I believe in the beginning God created the heaven and the earth, and God did it that way on purpose, just to make the Big Bang Theory look stupid. I do believe in the Big Bang, folks. I really do. The Bible teaches the Big Bang. 2 Peter 3:10 says, the heavens shall pass away with a great noise. In the original Greek, that's a Big Bang. So there's going to be a Big Bang. It just didn't happen yet, that's all. So kids, if you go to school and some professor says, do you believe in the Big Bang? You should say, yes, I do, and you better get saved and get ready for it. The Big Bang is coming soon to a city near you. By the way, if the Big Bang Theory were true, the matter would be evenly distributed. But it's not. It's lumpy. They're called galaxies, and in zillions of miles and nothing called voids. And to try to salvage the dumb Big Bang Theory, they've got all these wild theories of why isn't the matter evenly distributed? They'll say, well, maybe there's black holes, or maybe there's antimatter. They got all this stuff. It's all trying to rescue this crazy Big Bang Theory. And it's a dud, folks. It didn't happen. There are zillions of stars out there. I mean, lots and lots of stars. And we haven't even seen them all. If star births, they ought to at least equal star deaths, and they don't. We see a star blow up about every 30 years. It's called a nova or a supernova. Well, then how come there are only 300 dead stars out there that we can see, supernovas? Huh. That's only a few thousand years worth, isn't it? There ought to be trillions of them, if evolution were true. This fellow said, I have a little hesitation in saying that a sickly pall now hangs over the Big Bang Theory. Yep. I think it is stupid. Now, if you want to believe it, that's fine. I don't care what anybody believes. That doesn't bother me. But see, the problem is they want to use my tax dollars to teach that to your kids in our schools. And that's where the problem comes in. Okay? If you want to believe in the Big Bang, just enjoy yourself. But keep your religion at home. Okay? Because it is a religion. Then they tell the kids the Earth formed from a hot molten mass 4.6 billion years ago. This is part of the theory, and it's in all the textbooks. 4.6 billion years ago, Earth cooled down, formed a rocky crust. I think that is stupid, and I'll show you why. Was the Earth ever really a hot molten mass 4.6 billion years ago, and it cooled down? This textbook says, as Earth formed, the surface was like the moon. There were hot pools of bubbling lava. I don't think so. My Bible says the Spirit of God moved upon the face of the waters. So the Earth was not created a hot molten mass. It was created under water, which means it has to be less than 212 degrees Fahrenheit or 100 degrees centigrade, or it wouldn't be water, it'd be steam. So the Earth was never a hot molten mass according to Scripture. Then when you look in the granite rocks, you find little tiny halos made of polonium. Now these polonium halos are absolutely amazing. Robert Gentry, a friend of mine from Knoxville, Tennessee area, he has been studying radiopolonium halos for a long time. I met him back in the year 2000 and went down to his laboratory and I got to see some of the halos through the microscope. These little polonium halos are interesting because they have a half-life of less than a few minutes. If the rock was hot, when the polonium, radioactive polonium, decayed and sent out the little particles and made the halo, it would melt away. Like at 4th of July, they shoot fireworks up. Makes a circle. Does the circle stay there? No, it all falls down, right? There are probably none up there now from the last 4th of July, are there? You'd have to freeze the whole atmosphere to keep that sphere in place. This polonium would have to be decaying in a rock that is already solid. So the Earth was never a hot molten mass. Get Robert Gentry's book if you want a lot more on that. But all over, the granites all over the world contain these polonium halos. So it is stupid to say the Earth was a hot molten mass. We have scientific evidence it was not. Here they tell the kids, though, the Earth was hot with large pools of bubbling lava, and that is just stupid. It can't possibly be true. And one cell is more complex than a space shuttle. First, we have cosmic evolution. That would be the Big Bang. There is no evidence whatsoever for that. We'll get into that in just a moment. Then we'd have to have chemical evolution. See, the Big Bang supposedly made hydrogen. Well, how did we get 92 elements, plus the synthetic ones? I mean, how did the chemicals evolve? They don't talk about that much, but that would have to happen. Thirdly, we'd have to have stellar and planetary evolution. Did you know the stars would have to evolve? There's an awful lot of stars out there, folks, but nobody's ever seen one form. There's enough stars out there that everybody on Earth can personally own 2 trillion of them. We've never seen one star forming. We see them blow up from time to time. It's called a nova or a supernova. We've never seen one form. That's all theoretical. We've never seen it happen, okay? And I think it is scientifically impossible. See, then we'd have to have organic evolution. That would be the origin of life. How did life get started from non-living material? Now, according to the evolution theory, that would have to happen somewhere along the line, long ago and far away. Life had to come from non-living material. And yet, we've never seen that happen. There is no evidence that it can happen. They teach the kids it all started with a Big Bang 20 billion years ago. A Big Bang. I like to ask them some simple questions. What exploded? And where did it come from? And where did the energy come from? Et cetera, et cetera.
It's the biggest mystery in science to try and understand where the energy we see in the universe comes from.
Thank you so much for joining us tonight.
We are all gathered here at the end game of developmental processes on this planet. We are about to become unrecognizable to ourselves as a species. Our technologies, our religions, our science has pushed us toward this for thousands of years without us awakening to what the denouement would be. Now we stand close enough to it that I think all but the most lumpen among us must feel the tug of the transcendental and the transformative. Well, I think the problem is that we have too long ignored the possibility that reality is stranger than we can suppose.
The fourth way is, who knows, maybe someday somebody will figure it out.
Well, novelty theory is something I've been working on since the early 70s, inspired by psychedelic plant experiences in the Amazon, to attempt to look at time and really deconstruct it and attempt to understand what it is. And this has been a wild intellectual ride, leading to some pretty easily stated conclusions. One is that novelty, which is my term for complexity or advanced organization, novelty increases as we approach the present moment. The universe you and I are living in is a far more novel and complicated place than the early universe was. So I see the cosmos, if you will, as a kind of novelty-producing engine, a kind of machine which produces complexity in all realms, physical, chemical, social, whatever, and then uses that achieved level of complexity as the platform for further complexity. Well, this explains our present circumstance. It explains the rush toward all forms of new technology and social organization in the new millennium. But you don't have to be a rocket scientist to understand that if the universe is complexifying faster and faster, an epoch, a time will come when this rate of complexification is occurring so rapidly that it will become itself the overwhelming phenomena in the world of three-dimensional space and time. And I call this the omega point, or the transcendental object at the end of history. And I believe it is not that far off, that with the emergence of global internet, a human population of several billions, an electronic noosphere, that we are now within the shadow of this transcendental object at the end of time. Our religions sense it. That's what gives them their apocalyptic intuitions. And I think the ordinary man and woman in the street sense a kind of built-in acceleration to time itself.
And God said, "Let there be light."
It began in the sea, some 3,000 million years ago. Complex chemical molecules began to clump together to form microscopic blobs, cells. These were the seeds from which the tree of life developed.